Hello, this is the water testing lesson for C3, C3.1, the first lesson in the qualitative testing topic. Um, we're going to we're going to revise some tests for ions. I've got some videos where I do the tests for ions, which I'm going to incorporate into this lesson. And we're going to begin by discussing the difference between qualitative and quantitative tests. Please take a look at the lesson outcomes. Have a pause, take some notes, make sure you rewind the video if you don't understand anything, and I hope you learn loads. Okay, let's scroll down. So, what is a qualitative test and what is a quantitative test? Okay, let's just write this down. So, qualitative tests. Right, let me change the color. Right, so qualitative tests are tests that, well, in chemistry, they're tests that only identify which chemical is present. Okay, so they only identify the presence of a chemical. They do not measure the amount of chemical there. They don't measure the amount of substance. For example, flame tests are only qualitative. Most precipitation tests are only qualitative, unless of course you collect the amount of precipitate and then weigh it and dry it, but that's another story. Quantitative tests, if you look at the word quantitative tests, as the name suggests, measure the quantity. Go back to blue. They measure the quantity of a substance in a sample. Now, some of you in class that are working towards the A star grade will be able to adapt the precipitation tests we're talking about into a quantitative test. But the example would want you to know as a quantitative test is the titrations. Okay, we won't be talking about that in this lesson. Fair enough. Okay, so make sure you take those notes down. Now, we're going to move on to flame tests. Okay, flame tests. You need to know calcium, sodium, potassium, and copper. In C2, you learn them as tests for cations, and you're going to learn them for this again. So let's just quickly knock up a table. So let's do the headings of the table in black. So we have the element, we have the symbol, and we've got the color of flame. Right, so first up we have calcium. Let's just put that in red. Right, now calcium compounds. If, for example, you were to place calcium chloride as is spray it on a flame or put a bit of solid. Well, obviously the calcium compound needs to contain calcium ions. It's in group 2, loses 2 electrons, so it's going to have a charge of +2. It will give you a beautiful brick red colour. Next up is sodium. Now, I must say there are plenty more metals or cations that will produce beautiful colours, but the syllabus only requires you to know 4. Sodium produces a very familiar orange-yellow colour. Lots of street lights produce this orange-yellow colour that I'm going to show you in a few videos in a second. The reason they're orange-yellow is because they contain sodium, and they're adequately named sodium lamps, which is why they're orange-yellow in colour. The next one is potassium. 1 T, 2 S's. Symbol is K+, because as like sodium, they're both in group 1, so they lose 1 electron, so form ions with charge of K+, and that produces a nice subtle lilac colour. Following that is copper, probably the coolest of the colours. Copper 2 ions are copper 2+, and it produces this wonderful green blue colour.
Right, copper's first. Right, shall I do copper first? Just look at the flame. Right, no flash, because you won't see it. Right, move out of the way, please, Ehab. Right, copper chloride.
Wow.
Okay, produces a blue-green flame. That was really nice. Wonderful. That was copper chloride. Copper. Next one. You do it. Lithium. Right? Which is that lithium?
Yeah.
Wonderful. Look at that beautiful red colour. Enough. Okay. Wait, we need to. Is that
Potassium.
haven't we got 5? Right, potassium next. Alright, see that lilac colour. Wonderful, enough.
This guy's so best in there.
Right, sodium. Is that the last one, yeah? Sodium. Yeah?
So shit.
Orange, yellow colour. Right? Okay.
One more for you, Big Son.
Right, wonderful. Thank you very much.
Fine, so you've seen the flame test now. So we're going to move on to this C. Alright, so we've done D. You've seen the flame test. Hopefully you can explain this in a qualitative and a quantitative test and recall the colours produced by different metals in the flame test. So now we're going to move on to the C grade stuff. And I'm going to talk about the silver nitrate test for halides first. So let's do that one first. Then I'm going to move on to the sodium hydroxide precipitation test. I'm going to babble on a bit in the video, and I'm going to also show you the video test. So let's do the silver nitrate test for halides. Scroll back down past the flame tests. So let's choose a nice blue this time. So we have the silver. Whoops. Where's that rubber gone? That's an unsightly L. So the silver nitrate test for, whoops, gotta get used to this pen, halides. Alright, first up, I hope you all know what a halide is. Okay, the halides are essentially halogen ions. Okay, now the halogens are basically group 7. So the important halogen ions, I mean, we just call them halides. So you should know that all non-metal, all simple non-metal ions end in "ide." So you don't have an oxygen ion, you have an oxide ion. Likewise, you don't have a fluorine ion, you have the fluoride ion, F minus. You have the chloride ion, Cl minus. You have the bromide ion, Br minus. And finally you have the iodide ion, I minus. I haven't done the fluoride test for you on the video next. I've just done chloride, bromide and iodide. However, I'm just quickly going to give you the chemistry of the tests. Well, I'm just going to quickly give you the chemistry of the tests now. So, let's do this in a different color. So, why don't we take black this time? So, silver nitrate test for halides. A lot of the time it's called the acidified silver nitrate test for ions because you pre-treat your sample with concentrated acid, namely nitric acid. You do this in order to remove any unwanted solids that could interfere with your test. Now, nitric acid is ideal because A, it's pretty corrosive, and B, it doesn't contain any ions that could interfere with the test. The least sensible acid to use would be any acid that contains a halide in it, namely hydrochloric acid, because hydrochloric acid itself contains chloride ions, so using that would be a bit backward, really. Because the test afterwards would test positive chloride ions because you've just added chloride ions. Let's use a bit of purple. So, silver nitrate test for halides. You pre-treat the sample with concentrated nitric acid, hence the name acidified. Then it's quite simple. You add a few drops of silver nitrate, which is AgNO3. Solution, that's what the AQ stands for. And then what will happen is if a halide is present, you will get a precipitate. A precipitate is formed. Now, I hope you know that a precipitate, let me underline that, drop that there, is just an insoluble product. Okay? Alright, wonderful. So let's just drag that down a little bit. So what do you get? So if I have the name of the halide, and then we're going to have the precipitate formed. Okay, here's a table. What we have, okay, white, cream and yellow. I normally call them different, but doesn't matter. Let's go back to red. So if we have chloride, Cl minus, the precipitate formed is this beautiful white color. If you have the bromide ion, you have a cream or an off-white color, I like to call it. And the iodide ion gives you this wonderful yellowish color. Alright, so there they are.
Acidified silver nitrate test for halides. Right, I'm going to be using potassium chloride, potassium bromide, and potassium iodide, some nitric acid, and the test reagent, silver nitrate. Notice how it's in a brown bottle. Okay, it's in a brown bottle to protect it from the light, because light can cause the silver ions to reduce back into a metal, which basically makes it go off. So first up, let's do it with potassium chloride first. I'm going to add a few drops to a test tube. Okay, add some more so it's a little clearer. Then one will add nitric acid. You don't always need to add nitric acid, but I'm just adding it for completeness. An acid is added normally to these tests to remove any solid that you might have that could interfere with the test. We use nitric acid and we don't use hydrochloric acid because hydrochloric acid contains chloride ions and would interfere with the test. Nitric acid doesn't contain any ions, well, it contains nitrate ions and hydrogen ions. It won't interfere with the test. Silver nitrate is our test reagent. We add this next. Okay, a few drops. And if you watch closely, you get a beautiful white precipitate form. Okay, so there's first I'm going to put this test tube here. A pure white precipitate. I hope you can see that. Next, we're going to try it with bromide ion, so potassium bromide. Again, I will add a couple of squirts into a test tube. Okay, notice potassium bromide is a colourless, translucent liquid. Solution, I should add. Then I'm going to add some nitric acid in order to remove any solid. Okay, there is none there, but just for completeness. Then we're going to add the test reagent, silver nitrate. Okay, notice now that we have another white precipitate, but it's more off-white or cream in colour. Finally, the third ion we're going to test is the iodide ions, again with potassium iodide. A few squirts into a test tube. Some nitric acid in order to remove solid. And the test reagent, silver nitrate. Just a few drops is all that necessary. Notice how we get a yellowish precipitate. Right, so just to show you again, going from your right to left, chloride, pure white precipitate, bromide, an off-white precipitate, iodide, a yellowish precipitate.
So here are the actual equations for the halide test, the silver nitrate halide test. Right, okay, we're staying blue. Let's stay in blue. Why not? So, for example, let's say I had a solution of sodium chloride. Right? Solution of sodium chloride. That's shown by this AQ symbol. It stands for aqueous solution. And I add a few drops of silver nitrate. Okay? Which is also an aqueous solution, AQ. This is going to form a soluble product, sodium nitrate, and my insoluble precipitate, silver chloride. I'll show it's insoluble with an S. This is my white precipitate. Alright? Likewise, let's try a different example. Let's say I had some potassium bromide. Okay, potassium bromide. And it's in solution. I add some silver nitrate. Again, soluble. this time I'm going to get my soluble potassium nitrate and an insoluble silver bromide. This is a, what did we call it, a cream precipitate, cream color. It's not actually cream. Yep. Okay, now let's try an iodide. This time, why don't we try a different iodide altogether? Let's try calcium iodide. Now this got a slightly different formula because calcium's in group 2, iodine's in group 7, calcium ion is 2+, the iodide ion is I-, so I need 2 iodide ions for every 1 calcium ion, 2+, 1-, yeah? So to cancel out the charges, the formula for calcium iodide has got to be Ci2-. Now presuming this is soluble, so let's say I have a solution of that. I add some silver nitrate. Okay. Again, what will my precipitate be? Right, well, my precipitate again is going to be silver iodide. Right, so S. This is my yellow precipitate. Now you see, silver ions have a charge of Ag minus. Ag plus. What am I talking about? Okay, they have oxidation state of 1. Okay, even though it's a transition metal, silver normally only, as far as I know, well, I'm sure it does at other times, but it forms ions of +1. So iodide -1, it's got to be AgI. My soluble substance, calcium nitrate, alright, has got to be CaNO3 in brackets, 2 of them. Now, why is this? Well, the nitrate ion, you should know from C2, has a charge of -1. Symbol's NO3 minus, whereas the calcium ion has a charge of +2. So in order to form calcium nitrate, I need 2 nitrate ions for every 1 calcium ion. So the formula has to be CaNO3 2. Alright, let's stick an AQ there to show it's still soluble. Right, now I need to balance this, so let's just change the color to do that. So here I have 1 calcium ion, I have 1 calcium ion. That's wonderful. I have 2 iodide ions. I only have 1 iodide ion here. So all I can do is stick a 2 in front of the silver iodide. I can't start sticking a 2 here because I changed the substance. Okay, so the iodine's now balanced. But look, I now have 2 silvers, 2 silver ions, and only 1 here. So I stick a 2 there. So now my 2 silvers are balanced. 2 silver, that's okay. But now I have 2 nitrates. But never fear, because if I look here in calcium nitrate, I also have 2 nitrates. So now this is balanced.
Okay, the sodium hydroxide test for metal cations. Right, I'm going to test aluminium, calcium, copper 2, iron 2, and iron 3. The test reagent will be sodium hydroxide, hence the name of the test, which is nasty stuff. It's corrosive, gets in your eyes, you'll be in trouble. This is only 1 mole of sodium hydroxide you're using, so not that dangerous, but still one must wear goggles. Aluminium nitrate first, or aluminium first. Going to add a few drops. Okay, as usual, we use a strong acid to dissolve away any unwanted solid. Okay, in this case I'm going to use hydrochloric acid. A few drops of that. And now the test reagent, sodium hydroxide. Watch carefully. Now, hard to see this, so I'm going to add a bit more. So the precipitate isn't as clear as with the others, but
if you look carefully, there's some cloudiness going on here. Right, that is the aluminium precipitate. Next up, copper 2 sulfate. Now, these solutions are quite clear, well, all except the iron 2, so I'm not going to add the acid so as not to dilute the solution. So notice how copper 2 is a beautiful, bright blue colour. Okay, copper 2 ions are bright blue. Okay, so copper 2 sulfate. I'm going to add some test reagent. And notice you get this snot-like precipitate form. This beautiful royal blue, gelatinous, that means jelly-like precipitate. Copper 2. Here I have some iron 2. Now iron 2 is actually a blue-green solution. This doesn't look so blue-green because it's gone off a little. Okay, so there we go. I'm going to add some test reagent, and you get this green precipitate. Another green gelatinous jelly or snot-like precipitate. Please say gelatinous in your exam, don't say snot. Okay, that was iron 2. So iron 2 gives you a green precipitate. Finally, we've got iron 3. Okay, pipette's not working very well. There we go, 1. Oh, I haven't done calcium. Okay, here's iron 3. Right, let's add some hydroxide. If you watch, let me do this a bit closer to the camera this time. And see, you get a red-brown gelatinous precipitate. Finally, I move to calcium. Samples of this. Now I want to show you something special with calcium. Calcium, you see, also forms a white precipitate. Okay, here we go. See that? Wonderful white precipitate. However, okay, let's have a look at the chemistry of the sodium hydroxide test for cations. So let's say we have some copper 2 chloride. Okay, copper 2 has ions of C2+, chloride ion is Cl-. So for the formula for copper 2 chloride, it's got to be CuCl2. Right, it's soluble. So, and I have a solution of it. It's this wonderful blue solution. Looks just like copper sulfate. I add some sodium hydroxide to it. Solution. That's how I show the AQ. Now this is going to make a soluble product, NaCl, sodium chloride. Show it soluble by adding AQ, and then my insoluble copper 2 hydroxide. Now notice how I put the hydroxide in brackets and write a 2. I also show that it's insoluble by adding the S. This is my blue, it's like a pale blue gelatinous precipitate, as you saw. Now the thing you must note is that all metal hydroxides except group 1 excuse me, except group 1 hydroxides are insoluble. In fact, group 2 hydroxides are sparingly soluble. Right? They're not very soluble. Calcium hydroxide is just marginally soluble. All the group 1 hydroxides are soluble. Sodium hydroxide is soluble. Lithium hydroxide is soluble. Potassium hydroxide is soluble. The transition metal hydroxides and all the other metal hydroxides are very insoluble, which is basically the basis of the test. If you make one in a reaction, you get a precipitate, which is exactly what's happened here. Now this isn't balanced. Let's balance the equation. Start anywhere. Remember, you need to work backwards and forwards. So here I have two chloride ion. Well, here I have a copper ion and a copper ion. That's balanced. I have two chlorides here, but only one here. So all I can do is stick a 2 in front. Now I have two chlorides, two sodiums, one sodium. Right, two chlorides, good. Two sodiums, one sodium. So I stick a 2 in front of that. So now my sodiums are balanced. Now I look, I have two hydroxides. Two hydroxides is balanced. Okay, wonderful. Let's try a different one. Let's try iron 3 chloride. Okay, now iron 3, as we said before, is Fe3 plus. Chloride is Cl minus, so I need 3 of these for every one of them. Let's say I add some sodium hydroxide. Okay, notice how I leave a gap for some balancing, just in case. Alright, we're going to end up this time with some, again we're going to end up with sodium chloride. Has to be NaCl, because, well, you should know the formula for that, but if you don't, sodium's in group 1, chloride's in group 7, Na plus, Cl minus, 1 to 1, job done. Right, iron 3 hydroxide. Okay, now the hydroxide ion is OH minus. The iron is Fe3 plus. To work out the formula, I say FeLH. This 3 goes over here. Now I can't leave that here. I have to stick brackets around it, otherwise it will look like I have 3 hydrogens. But what I want to show is I have 3 hydroxide ions. There's an imaginary 1 here that you are going to add here, but you don't write it, so it's FeOH3. Okay. This is a metal hydroxide. Only group 1 metal hydroxides and group 2 a little bit are soluble. So there's my precipitate. And this is my red-brown gelatinous precipitate.